Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about open sourcing, an important component of Android graphics. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett. Episode 465, recorded January 3rd, 2018. DRM HW Composer. This episode of FLOSS Weekly is brought to you by IT Pro TV, the fun and entertaining way to sharpen your IT skills. Visit itpro.tv/floss and use code FLOSS30 to get a free 7-day trial and 30% off a monthly membership for the lifetime of your active subscription. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin@Stonehenge.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day and not aware of it, projects you might want to go and play with right after the show. Today's probably one of those. Joining me once again, Jonathan Bennett. Welcome back to the show.
Hey, Randall, good to be here once again.
Well, you know, I haven't seen you since last year.
It's been literally forever.
Yes, exactly. And we're both in exactly the same place that we were for the previous show that we did the last show of the year last year. I'm home in my home in Beaverton, which I'll be at only until Friday, and then I'm off for a 4-week road trip. And you're obviously still in Oklahoma, yes?
Yes. Here in the lair, the corporate headquarters, the home office.
Cool. Well, today we have a show that's a little unusual in that it's probably going to be fairly geeky. We've had a lot of geeky shows over the years, but usually they're geeky shows that I know a lot about. I don't know a lot about this because it's about Android development. And we're going to be bringing on in a few minutes Robert Foss, who is the co-maintainer of DRM HWC. And he's also a contributor to Mesa and the Linux graphics subsystem. And he also builds electronics and does software art. But we're going to be talking about this DRM HWC. Now, it's something to do with Android development. And more particularly, it's something about, here, I've got a tab that actually gives me a little bit more information. It's sort of an open source stack that replaces the HWC stack that it was introduced into Android 3.0, and it's evolved steadily over the years. So it's basically, its primary purpose is to determine the most efficient way to composite buffers with available hardware. And its implementation is device-specific, and it's usually done by the display hardware OEM. Well, of course, that means that it's proprietary based on the hardware platform. And what DRM HWC tries to do is tries to make that an open-source project, so it's open source all the way from top to bottom. That's my understanding of it. Jonathan, can you fill me in and see if that even makes sense?
Yeah, so you're from what I could tell, you're in the right ballpark. It's definitely about graphics. I think one of the interesting things about this is it's trying to take, I don't remember the company that did it before Google bought them, but back when Android was created, it was a hard fork of the Linux kernel, and they went totally a different direction. And in the years since then, the open source guys and Google have been kind of trying to march those two projects back together. And Torvalds has said a couple of times that he anticipates in the near future that Android will no longer be a fork of Linux. They'll get everything under one tree, and DRM HWC is a part of that. It is all about getting the way that Android does graphics to work with the existing Linux graphics stack. So all kinds of interesting topics to till up and look into here.
Well, we could keep chatting back and forth about what this actually is about, but we do have an expert we're going to bring on in a few minutes about this. But before we do that, I do have a very important message, because this episode of FLOSS Weekly is brought to you by IT Pro TV. With the new year come resolutions. Whether you're looking to jazz up your resume or looking to consider an exciting new career in tech, make your professional resolutions a reality this year with IT Pro TV. IT Pro TV offers over 3,300 hours of on-demand training with more than 125 hours added weekly. You can stream IT Pro TV's courses live and on-demand worldwide via Chromecast, Roku, Amazon Fire TV, Apple TV, PC, or by using their iOS or Android apps. IT Pro TV does IT live every day, so you know you're getting the most current IT training. Courses include Certified Ethical Hacker, Kali Linux, Linux Security Techniques, ITIL, ISC Security Certs, and more. Be sure to check their calendar for upcoming courses. You can advance your IT career and prepare for certifications you're interested in. CRISC, CISSP, CISM, CISA, or CEH with IT Pro TV's individual membership. You can also check out IT Pro TV's team solution for group pricing and access to the IT Pro TV Supervisor portal. You can gain full control over your team's training schedule, create custom groups and training assignments, and see individual and group analytics. You can view logins, viewing time, video downloads, course completion tracking, and more. So join the more than 85,000 IT Pro TV members today. Check out itpro.tv/floss and find out how IT Pro TV can offer you or your team the best IT training solution. You're going to get a free 7-day trial when you sign up for individual monthly membership using their offer code FLOSS30. You'll also receive 30% off your subscription for the lifetime of your active subscription. If you're interested in learning more about IT Pro TV's team solution, you can also sign up for a free demo of their supervisor portal. Go to itpro.tv/floss and use code FLOSS30 to try it free for 7 days and receive 30% off. Friendly training, binge-worthy content, life-changing results. And we thank IT Pro TV for their sponsorship of Floss. Let's go ahead and bring on our guests. Robert, welcome to the show.
Hey, thank you.
And where are you speaking to us from?
I'm in Berlin, Germany.
Okay, now, you could see that I stumbled a little bit through this because I'm not an Android programmer yet. Why don't you give us the 30,000-foot view? What problem is this solving?
So this project is solving the problem that the open source Linux graphics stack doesn't really have all of the important bits that the Android graphics stack has. So there are some parts of the Android graphics stack that simply have no open source equivalent. And that's where this part fits in. It enables your graphics stack to be more efficient when dealing with graphics buffers.
Now, is this only going to be useful when I've got like a desktop unit? Or, I mean, is this replacing something in the Android stack?
So normally the Android stack has like an OEM supplied driver that's not open source, and it contains this HWC component, and that doesn't exist at all in the open source space. So if you want to run a fully open source Android graphic stack, you need this component somehow. So it's for a desktop or a cell phone or any embedded application. It's wherever you'd be using open source graphics drivers and Android at the same time.
And where does the graphics driver fit in the process? I think it's somewhere below my application, right?
Right. So there's sort of a stack, and there's the kernel, and on top of that, there's the graphics driver. It partially lives in the kernel, partially lives in user space. And on top of that, there's the HWC part, the hardware composer, which in Android is done through a protocol called creatively HWC2. And that's then used to communicate with the applications and manage the different parts or the different graphics buffers of different applications so that they can coexist and also be rendered efficiently onto the display buffers.
Okay, so what is this? Why is this proprietary on standard Android?
Well, hardware vendors typically feel like that it's part of their special sauce. It's what makes their hardware special, but in reality, they all ship basically the same hardware. So they're not very eager to share the implementation of this stuff. But that doesn't mean there's no need for an open source implementation of this stuff. The open source graphics drivers don't really have an implementation for this. So some people inside of Google, Sean Paul and Zach Reisner, decided to write DRM Hardware Composer in order to be able to use the open source graphics drivers.
Now, would this be different then? Are there variations of this for each of the different platforms?
So, yes, the display hardware parts are slightly different, but the majority of the functionality is pretty much identical. So having a generic code base like DRM hardware composer allows you to have the shared functionality in one place, and then just add like quirks for the specific hardware that's different, like the Intel graphics or the Intel display hardware might not support this or that pixel format, so you might have to add like a quirk for that, and that's what DRM hardware composer is meant to do. It's just collect all this stuff in one place and enable everyone to use open source graphics drivers.
And you said there were some guys at Google that started this and created the project?
Yeah, this project was started by Sean Paul, and Zach Reisner has also done a lot of work on it. It was initially a part of the Pixel C project, and it shipped on that hardware since they were using the open source NVIDIA graphics driver for that project.
Hey, so I wanted to jump in. We have a couple of questions from our chat room. First off, Keith512 says, This is what Mesa is for. I think he's asking, is this just the same thing as Mesa, or what's the connection between DRM HWC and Mesa?
So if we look at the stack again, there's the kernel, which contains part of the graphics driver, and then on top of the kernel there's the user space stuff, basically everything else. And the user space part of the driver is Mesa. And DRM hardware composer sort of is stacked on top of Mesa and two other projects. So it doesn't replace Mesa, it's rather built on top of it.
So I wanted to follow up with what does DRM HWC, what does it provide that the regular DRM and that Mesa doesn't? What are the special Android hooks that make this magical when it comes to Android? So
Mesa doesn't implement the HWC2 protocol at all, or API at all. So something needs to implement it. And that's where this project comes in. It simply implements this API and allows buffers to be managed intelligently.
So that API, what does it do that OpenGL or Vulkan doesn't do?
Well, you could use Vulkan or OpenGL to do these things, and in fact, DRM hardware composer sometimes does that as a fallback. But when you use the GPU graphics hardware to do this buffer management, you'll pay a pretty heavy price. And instead, you could just use the display hardware that's far more energy efficient and possibly also faster at doing this stuff. So that would not only allow you to save energy, it would also free up time on your GPU, allowing it to do what it actually needs to do. So it's sort of a gain in performance and energy efficiency at the same time.
Now, what exactly is buffer management in the Android context? Is that like where Android has multiple different apps that it kind of has active, not active, but it keeps in memory at the same time and can very, very quickly switch between them? Is that what buffer management refers to?
Yeah, basically. So many things on the Android desktop are separate graphics buffers. So if you look at the little bar on top with the time and a few notifications in it, that's a graphics buffer. And the background on your Android desktop is a buffer. And there are a few more parts like that that are separate buffers. And they need to be handled, like they need to be combined into a single buffer before it's being read out to the display. So that's what this compositioning refers to. That's the actual hardware composing that's going on. And I mean, having these small buffers that don't overlap is sort of the best case scenario. It's the simplest thing. But when you start having buffers that overlap and there's opacity and stuff like that, it's a reasonably intensive process to to combine them. And that's why you don't really want to do it on the GPU if there's other hardware that's better at it.
Now, is this only applicable for an Android device? Is it only for cell phones, or does this project have a kind of a life outside of Android and cell phones?
Well, it could be used wherever the HWC2 API is implemented, but it's only implemented in Android, and it probably won't be implemented anywhere else, since Wayland does similar things, but in its own way. So there's no need for other platforms. So the X server, for example, doesn't really do this. Like it's so old that it doesn't really have support for doing this. And if you were to run the X server on a mobile device, you'd be paying a pretty heavy penalty for not having support for this energy efficient hardware.
So you've mentioned HWC2 a couple of times. I'm curious, was there an HWC1 back in the annals of past?
Yeah, there was. I sort of came onto this project at the time HWC1 was being replaced with number 2, and the reason for this is that HWC2 requires some new kernel support for synchronizing buffers and handling that in an intelligent way. And when that was introduced in the kernel, some updating was needed to DRM hardware composer, and that's what I started doing.
All right. Now, refresh our memory. I know you mentioned this, but are there any devices that actually ship with this project rather than a proprietary version of it?
The Google Pixel C did. It's now an older device, but it's also been adopted in other products that I don't think have been released yet. Don't
break any NDAs now.
Exactly. No, it hasn't been released in any other devices as far as I know. But you can run this yourself in an emulator, or you can run it on a development board. It's not all that hard to get up and running, actually.
Is there an HWC layer in the Chromebook, the Chrome OS as well?
Yes and no. The Chrome OS is... It actually supports running Android applications, and it does that by running an entire Android system image inside of Chromium OS, which means that it's running the very same code that Android is. So yes, it does run this in sort of a roundabout way, but only when you run Android applications on Chrome OS. And
one of the interesting things about Android, one of the great things, as it's open source, is we have all of these third-party spins of it, and you have some of the guys like Lineage OS, that the fork of CyanogenMod. It's polished up to where it's basically a full-blown release. Do any of those spins use the DRM version of HWC in what they ship?
Not as far as I know. In terms of people shipping this stuff or using this stuff, I think the Android x86 folks are using this, and that's what they choose to ship. So what they're targeting is like desktop Android, which means running Android on top of the Intel graphics stack.
Now, for someone to be able to use this, to make use of it, there's got to be an open source video driver for the video hardware. Is that right?
Yeah, a graphics driver for the GPU. Yeah.
And that's, I suppose, not something that someone can whip together in an afternoon. That's kind of an intensive development process.
Well, there are some people out there that are pretty good at it, but maybe not an afternoon.
And so what is the landscape, especially the kind of hardware you see? And most of us are interested in our cell phones when it comes to Android. What does the landscape look like as far as as support for these different video devices with open source support?
So I would say that support is coming along. Some vendors are notoriously hard to provide support for. But to name a few, there's Freedreno, which Rob Clark has been doing a lot of amazing work at. And it's basically fully functional. Even very recent GPU hardware is supported and will at the very least boot. And you'll probably have pretty decent performance too. And recently there's been the EtnaViv driver for the Vivante GPUs, which are interesting because they're very low cost and also available in lots of embedded targets. So if you want an embedded platform that's cheap and runs an entirely open source graphics stack, that's an interesting target. And since recently, there's been a lot of work by a bunch of people to enable it. And the currently available most high-end Vivante GPUs are supported, and that's what I've been working against, and I've had very few problems. Additionally, there are other GPUs that are less well supported, like the ARM Mali GPUs, for example. There are some. There's a project called Lima and Lima NG and Lima NG NG, and they are all in sort of the early days of supporting the GPU hardware. I saw a video today about someone landing texturing support. So there's still work in progress, but it's very early days for it. Something that's a bit more close to actually working would be the Raspberry Pi graphics part, the VC4, which, as far as I understand it, only is missing this memory synchronization support or buffer synchronization support. And when that's supported, it should work equally well as the Vivante and the Adreno GPUs.
That's interesting. The Raspberry Pi will be an important target to try to support. Now, you've talked about this project working on desktop Android. When someone is doing Android development and they run Android in an emulator, not one that actually emulates the hardware, but actually runs a copy of Android made for x86 or x86-64, does that run DRM Composer underneath the hood? Is that how that works?
That's a good question. I actually don't know. I'm not too familiar with the internals of the Android emulators. I know that there are, I think, 3 separate Google-sponsored emulators for Android that sort of target different niches, and I don't know what either of them use. I know that you can use the DRM hardware composer if you want to. You can fire this stuff up inside of a QEMU virtual machine and just run it. It does work. I've done it in the past, so it's fully possible, but it's maybe not super straightforward. But I've written a blog post about it, so if anyone's interested, you can just Google QEMU DRM hardware composer, and I'm sure you'd find the post, and there are instructions there.
Cool. Hey, I'll let Jonathan take a break here for a second. I had the same question in my head that Chumley also asked in our chat room, and that's, you keep saying DRM, but when I hear DRM, I hear digital rights management. I don't think that's what you mean, right?
Right. Yes. Somewhat unfortunately, the graphics subsystem in the Linux kernel is called DRM, and that's where the DRM part of this name comes from. It refers to the Linux kernel graphics subsystem.
Okay, but Linux kernel graphics subsystem doesn't have the letters D, R, or M in it. What do the letters stand for?
I don't know. I actually don't know.
I know. I'll jump in and help you out. It's the direct rendering manager.
Oh, yes.
Okay, good.
Of course it
is. Thank you for having a co-host that actually knew the answer to that. That's amazing. So let's talk about the project. So how many people are involved in this?
So there's a few. I would say like 4 or 5 people, but it's very on and off. When either of us have a project that relates to this, we'll commit like a patch or 2 or whatever we need to make it work. So it's very low intensity. However, patches are extremely welcome. I received one today, and it was really good. So I'm super happy about that. Just a new guy submitting a drive-by patch, and it was pretty good.
And what about debugging and testing? How do you do that? You have to have all these actual pieces of hardware so you can look at the code that varies a little bit from one piece to another?
Yes, if you want to make sure that you support the specific hardware devices, then yes, there's no way around that. But if you just want to get it up and running and see if your changes work, you can just use the emulator. That would work pretty well.
And debugging this has to be a bear. I'm a software person, but at least software I can insert breakpoints and stuff, but it's not real time necessarily. But how do you debug things that are more at the hardware device driver level?
Well, you can always just rebuild the kernel and insert some print case in there and see what's going on. It's maybe not the most elegant solution, but it's a quick way to get some information back. And this whole ecosystem, like the Android graphics stack, is fairly verbose and will talk to you in the same way that you'd expect from developing Android applications. So you'll see logcat logs, and you can connect using ADB and do the normal debugging.
And what's the most difficult part of this kind of an application, of this kind of a device driver? What's been some of the thorniest problems you've had to solve?
Well, it's hard in the beginning when everything is sort of broken. You get a device and you install this stuff and nothing works. Where do you start? What's actually the first problem you should be fixing? And I think that's the trickiest part. Okay,
and then it's just a matter of seeing what kinds of things show up on the display or what kinds of things come from your tracing to then give you feedback and input. Can you talk about that a little more?
Absolutely. Yeah. So, for example, the last device I worked with was we got it up and running. It displayed the boot animation flawlessly. And then when we got into the Android desktop environment, there was lots of corruption, and it was really hard to understand like where the corruption would come from. Mm-hmm. But it turned out that some compression modifiers or compression flags weren't communicated correctly. So we displayed compressed buffers instead of uncompressed buffers, which of course led to terrible corruption. And that's the kind of stuff you'd expect to see. Like you'll get very visual feedback when something's wrong.
That would make sense. I mean, this is a sort of visual thing, and I'm sure there's a lot of data flinging around too. I mean, if you're talking about composing from various individual buffers and doing essentially compositing work, are those always distinct or can they overlap?
The buffers themselves?
Yeah, well, not the buffers, but the actual visual representation once the buffers are brought together.
They can overlap. You can do stuff with opacity and stuff like that.
Okay. I think I'm understanding this a little bit better. So, so there's only a few people working on this. Is this project like just a labor of love, and you're just doing it to just give away to the community?
No, it's sort of a necessary building block. Like we need it. You can't really run Android with the open source drivers without it. So it's more of a necessity. And as far as these projects go, this one is fairly small and agile, which means that if you want to prototype some new graphics driver feature, and you want to argue for its inclusion into the kernel, you need it to be used somewhere, and you could probably pretty easily whip up support for it in DRM Hardware Composer, and then argue for your fancy new feature to be included into the kernel because of it. So it's sort of a vehicle for enabling new features in the kernel as well.
So your time, obviously. Well, I need to know: are you funded to do this, or is this something you're doing in your nights and weekends?
I'm 100% funded. So work for this has been paid for by a few clients of my employer, Collabora. They just need it for their projects, and that's where I come in. Okay,
and do you know, are there people getting paid at Google to work on this?
Yes and no. I don't think there's very active development, but they have some time to spend however they like. So in that sense, yes.
Hey, I wanted to jump in if I can.
Yeah, sorry.
So we talked a little bit in the intro about the Linux Android fork, and this really seems interesting to me. That DRM HW Composer, it seems to be part of this process where Android and Linux are marching closer together. They're starting to use some more of the same subsystems. Do you see this as maybe one of the players in bringing Android back into the mainline Linux fold?
Yeah, so this is sort of where it gets really interesting to me. It makes it easier for GPU vendors to start contributing actually open source drivers, and they can just take a small step by supporting DRM Hardware Composer, and then do more work afterwards. So in that sense, it allows them to more easily create a GPU driver and thereby move closer to the mainline kernel. There's also a lot of other work towards the goal of sort of having Android run on top of the mainline upstream kernel, but that's further away, or it's pretty far away, and it's a lot of work. But I think most people in the community want this. That includes Google, and it includes users and like power users. So hopefully it would happen. However, having the SoC manufacturers actually commit to being fully mainline is a pretty big step for them. And for some things, like for example, fingerprint readers, etc., it's writing drivers for devices like that is maybe not very interesting, because the drivers would mostly be like uploading a blob of firmware. So in that sense, we may probably never see a mainline support for all the normal peripherals of an Android device, but a lot of progress can be made, and hopefully will be.
Well, you triggered an interesting thought there. For example, the fingerprint readers, some of those are baked into the hardware encryption that some phones support. And, vendors actively don't want the user-facing kernel to be able to interact with those. You probably don't get a whole lot of that sort of a mindset with video card drivers, though, do you?
No, the rationale for the graphics people is more like this is our secret sauce. By sharing it, we decrease the value of our product. So I think it's a different mindset, and I think the fingerprint readers' point of view, or fingerprint reader manufacturers' point of view, is a bit more valid, and that upstreaming their things is maybe not even useful to anyone, whereas the GPU stuff would be useful to people.
Now, one of the interesting things we've seen with GPU drivers is I can think off the top of my head of at least two companies that have begun to actively support the open source drivers, and that's AMD, of course, and then also with the Raspberry Pi, I believe it's Broadcom, has started giving some support to reverse engineering and trying to create the open source driver. Is that accurate? Is that what you've seen?
Yes, but let's not forget about Intel that has been supporting open source graphics for a very long time and built much of what currently exists. So AMD is sort of a relative newcomer, and it's very nice to see them and contributing and doing good work. The same goes for Broadcom, which hired Eric Onholt, who's been doing amazing work. He's one of those guys who actually can sort of whip together a graphics driver in a weekend if he wants to. So it's nice to see someone paying him to actually do it.
Yes, you are correct. I was remiss to not mention Intel. I don't think very often about their video cards because they are sort of low powered and built into the chips. But you're right. Intel deserves some kudos for all of their work there. Intel kind of started that revolution as the first people to start open sourcing their drivers under Linux and therefore making it work with projects like this. Are there any other players that have made sounds that they're interested in trying to do something like that? Any of the other manufacturers?
I think Qualcomm with the Adreno GPUs have contributed some stuff, but they haven't been really pushing. Like I think they've been contributing where it's convenient for them for specific use cases, but not wholeheartedly pushing for an open source graphics driver.
Mm. And then one other question is kind of speculative on your part, I'm sure, but the future of Android, is Google and Android, are they going to continue supporting HW Composer? Is that the direction they're going? Or is some other technology, maybe Wayland, going to come along and replace it?
No one knows. I don't know. It's hard to see the future of Google. They sort of do whatever they want when they want it, and everyone sort of just has to follow. So I can't really even give you a decent guess. I would hope so, and in the sense of wanting more of a mainline kernel and using mainline Linux on Android devices, I think DRM Hardware Composer makes sense, unless they want to replace it with something that fills the same sort of slot in the stack.
And then who knows where Fuchsia's going to go? That might be in the same replacement era as well. So getting entirely away from Linux, but still on having it Google controlled. That would be kind of nice. I'm getting more familiar with Flutter and Fuchsia now as my time goes on too. So, hey, let's talk about something entirely different just for a few minutes. In the list of the URLs you sent us, one of the URLs was I'm sort of intrigued by it. It's about editing images as an audio script. Can you talk about that?
Yeah. Yes. I had a weekend to myself and was playing with FFmpeg. And since I'm somewhat familiar with pixel formats and stuff like that, I figured out that I can just export the raw pixel data from FFmpeg and do something with it. So I ran it through an audio filtering program and applied audio filters like echoes, or I added more bass to an image, like the first image here. This is just the bass turned up, which is kind of interesting looking. It's kind of hard to visualize this stuff normally, but doing it with images is kind of fun.
And if people want to see these images and they're only listening to this on audio, you can either download the video version of this show, or we'll have the URL in the show notes, so you'll be able to go check these out. So this is the one picture we're looking at there. That's sort of, you got like some timed echoes or something?
Yeah, it's just an echo filter and then a second echo filter applied to the first stuff. So we've got 4 Eiffel Towers instead of 1.
What made you think of this? This is interesting.
Not quite sure. I guess curiosity. Will this work? Will it be nonsense? And I guess it's somewhere in between. It's slight nonsense.
And I'm happy to hear that you have occasionally have a free weekend. I haven't had one of those in years, so it's pretty
cool. Good stuff. I'd recommend it.
Yeah. So how did you get in? Have you always been working in open source?
No, not at all. I worked for ARM for a bit, doing a video encoder decoder firmware, which is sort of related to this stuff in that you deal with buffers and pixel formats and stuff like that.
And with regard to the DRM HWC project, is it done, or are there still things that have to be done with it?
Yeah, I guess nothing's ever done, but there's definitely lots of work to be done. It's just a matter of someone needing it to be done and then actually committing to doing it. But there's a slow trickle of patches coming into the project. It's all hosted on the freedesktop.org mailing list, so anyone is welcome to contribute.
And I understand that there's some aspect of this that's being fed upstream into Chromium?
Well, it's rather the other way around. This project, as I mentioned earlier, was created by Sean Paul, who works for Google in one of their Chromium teams, or their Chromium team, maybe rather. So originally, it was a part of the Chromium OS project, and last year during the XDC conference, Google decided to liberate DRM Hardware Composer and make it an entirely open source project, which is a bit easier because we can be more flexible about accepting patches, and it is more work for Google to do it this way. So it was a very nice step for them to take, and it was very helpful.
And what license is this under?
GPL2, I believe.
Okay. Sorry for the tough questions. Yes. Hey, we're almost out of time, but I wanted to actually make sure that we covered everything you wanted to make sure we covered. Is there anything we didn't ask that you would like to make sure our audience is aware of before we have to let you go?
No, I think that's a pretty thorough introduction of what DRM Hardware Composer does and what the Linux graphics stack does as well.
And what kinds of additional help do you need? Do you need help translating? Do you need help fixing bugs?
I guess just people trying it on different hardware and seeing where it explodes so that we can fix it.
Sounds like a reasonable request for a call. Okay, well, it's been really fun having you on here. I've got two more questions I have to ask or else my audience gets mad. What's your favorite scripting language?
Python, I would say. Yeah.
Okay. Yeah, that's okay. That's a common answer. Very common answer. And what text editor do you use?
I use all of them. I don't really care. Whatever's open, I guess. So I use Atom, I use Vim, I use Nano, I use Pico, whatever's at hand.
That's being a polyglot in a whole different version. That's pretty cool. Hey, well, Robert, it's been really great having you on the show, and now I'm a little more understanding of how Android graphics are done, but I still long way. I still got a big learning curve ahead of me. But I'm glad you were able to put up with my questions at least, and give us more information.
Thanks for having me on.
It's very cool, very cool. Well, that was Robert Foss, who is the DRM HW Composer co-founder, co-maintainer. So what do you think there, Jonathan?
So it's interesting. You talk about understanding the Linux graphics stack. This is one of those projects that kind of sit there so that you don't have to understand all of it nearly as well. The way that Android works is it's all about kind of abstracting away the different things, and this is a layer of abstraction. I find it very interesting, though, that they're looking to support the open source drivers, which is kind of a big deal for, if Android opens up more in the future. Because Android is open source, but the way much of it is put together, you've got to have these closed source bits to be able to get anything done, which is unfortunate, especially for people like myself that would love to have a truly open device. I'll be very interested to watch this and see if there's any more manufacturers, video card manufacturers that try to jump on the bandwagon and say, oh, well, okay, we'll support this idea of making open source drivers for our hardware. If you have some of the big ones start doing that, then this project may suddenly explode and become one of the key parts of Android. But until there's open source drivers to build it on, it's not as essential for day-to-day use. So the future looks interesting for it.
Yeah, and I'm not too familiar with Android because I haven't had an Android phone yet, although I'll probably be getting one soon since I have to do software development for both platforms using Flutter. What if the entire stack is open source? Are there any DRM, using the other meaning of DRM, applications for it, like Hulu and Netflix?
Oh, that is kind of a rabbit hole. I'm not entirely sure. I think you may be able to spoof some of that. So on Android, the DRM platform, the digital rights management platform, is called Wildvine, I believe, and that's a rabbit hole in and of itself that I'm not super familiar with because I don't do a whole lot of actual hardware work on Android. So, but it does exist. I don't know how that would work with the open source drivers.
Yeah, especially I'm thinking if you have an open source driver that does the compositing, which is ultimately what leads to the screen, you could replace part of that with something that does screen recording, right?
Well, in theory you could, but you've also got this idea that, well, what if we encrypt that's what a lot of digital rights management does, is it literally takes your video stream and encrypts it and passes it through a layer as encrypted data and then decrypts it as it hits the screen. So I mean, there's the possibility that you could do something like that with an open source driver still.
Yeah. Okay. Anyway, you're right. That's a rabbit hole, but I think
that's a very deep rabbit hole.
I was just curious about it. I know it works on iOS because the Apple controls the whole platform. So somebody can, like Netflix, can just say, "Here's our Netflix app," and we know that you control everything down to the metal. So it makes it easier that way. Anyway, that's again off on a tangent. But here we go. So anything else before I talk about the upcoming guests?
No, I think we got a pretty decent overview of what the project is and kind of got into some of the pleasant weeds, in this case, about Linux kernel and Android development and what's going on there.
And we'd like to hear from any of you out in the audience who filled your buzzword bingo card. I think this was probably a good day for that. Oh, I'm so crazy. Anyway, let's talk about who's coming up, because we got a bunch of new ones actually this time. So I've been busy in the last 2 weeks trying to book new slots in. The slots were there. I was trying to book people into slots. I guess that makes more sense. Next week, the Open Mainframe Project to increase collaboration across the mainframe community, because most of the large heavy metal right now is running Linux, and so we want to make sure that there's cooperation across that for all that. Following that is Aragon, which are blockchains for democracy. Just added to the schedule sometime in the last couple of weeks, WireGuard, which is a modern VPN. It's faster, simpler, leaner, more useful than IPsec, they claim. So that's going to be really fun. Also just added to the schedule, NanoMessage, which is, we had ZeroMQ on this show like 6 or 7 years ago. And ZeroMQ had some issues, and so there was a fork of it called NanoMessage. Actually, it was called something else for a little while, but it's called NanoMessage now. And we're getting one of the lead developers going to come on and talk to us about this fork. So it's basically a way of getting servers and clients to talk together in all sorts of various configurations and able to have good proxies and good queue distribution, things like that. So that's going to be fun. Process Maker, which is a workflow manager. That'll be kind of cool. Scan Code, which obviously scans codes, but it's mostly to scan code, detect licenses, copyrights, package manifests, and so on. Just added to the schedule, my dear friend Jim Brandt, who I worked for many years over at the University at Buffalo. You have to be so careful not to say University of Buffalo. They get really mad when you do that. It's Sunny University at Buffalo. Anyway, he's now the head of the Perl Foundation, and we haven't had a Perl show on for a while, so I thought I bumped into him, I forget where it was, one of the open source conferences, and he said, yes, I'll go ahead and be on your show to talk about, this will be all things Perl. So where's Perl these days? What's happening with Perl 5 and Perl 6? What projects are being worked on? How are things getting funded? Perl Foundation also manages the Yet Another Perl conferences, which are now being renamed back to Perl conferences, just normal conferences, back to TPC, the Perl Conference. So that's going to be a lot of fun. And also just added to the schedule. So there's 4 new ones this time. GitLab, which is basically the open source GitHub. We're going to have the leader of that to talk about what GitLab is and how you can use it, both host on premises or put in the cloud or using their services as well. That's a lot of fun. So we've got a lot of new shows coming. We're booked all the way to March, which is really cool. So I can actually lay back just a little bit, but I still have a few emails I'm waiting to hear back from people. That's all, of course, on the big spreadsheet. You can get to the big spreadsheet at the homepage for this show, which is twit.tv/floss. And if you have any other suggestions, again, please tell the project leader or community coordinator to email me, merlin@stonehenge.com. My address is there on the homepage. We do a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. We took a number of questions from there today. Shumley, I'm remembering you, but I don't remember how many other ones we had. Anyway, and remember, it's always a number of questions because the number could be 0. So, yeah. I'll love figuring that out one day. Okay, you can follow us on FLOSS Weekly, Google Plus, and at FLOSS Weekly on Twitter. You can follow me at Randall L. Schwartz on Google+, and at Merlin, M-E-R-L-Y-N, on Twitter. I'm going to be around for the next 2 weeks, but then I'm going on a cruise ship for 2 weeks. I'm taking off out of San Diego, going north through the Panama Canal, ending up in Fort Lauderdale after hitting maybe 3 or 4 other countries. It's a wonderful, I think, 14 or 15-day cruise. That'll be a lot of fun. During that time, though, I do have co-hosts who are becoming hosts for those 2 weeks. So we are getting everything all squared up, so the show will not be interrupted. We will continue on, even though I am going to be sitting there with some fruity drink with a little umbrella in it somewhere on a deck while going through the Panama Canal. So that should be pretty fun. So, and I won't be able to do the show from there, obviously. So anything you want to plug there, Jonathan?
Sure. I'll give my standard commercial about CypherDyn and FWNOP. We are looking into the problem of being able to do secure remote access into legacy devices and even things with serial ports. And so if that's something that anyone has a need for, feel free to hit me up. You can get me at JP. Let's see, where is it? Over here at JP_Bennett or jbennett@cypherdyn.com. And if that's something you're interested in, let us know.
Well, Jonathan, I really appreciate your level of Android knowledge on this particular week. It really helped me out, so I'm glad you asked questions that I wouldn't even thought to ask. So that was good. Hopefully I didn't sound too stumbling on some of my questions, but that'll be for the audience to decide, I guess. So anyway, next week's is going to be a little bit more open mainframe. That's also about hardware. Gosh. Okay. Well, no, it's about Linux. So I have to get a Linux expert as well, since I'm not an expert in Linux either. So anyway, we'll figure it out. We don't have the co-host selected next week yet, but we'll figure it out. It might even be you. We'll never know.
Might be.
You never know. You're always like so available. It's really kind of nice. So anyway, Jonathan, thanks.
It's the beauty of being able to set my own schedule. I can always say, yes, I'm available then.
Yes, I sort of set my schedule, but sometimes I can't. Like the cruise doesn't move just because I want it to be in a different day. And but I can set whether I'm in Beaverton today or Tijuana next week. I can kind of control some of that, so it's not too bad. Anyway, that's all we have for today. So we'll see you all again next week on FLOSS Weekly.